And we are live. Thank you, everybody, for another Developer DAO workshop. We have special guest Ryan from Hiro. We're going to be learning about the difference between Solidity and Stacks. Well, Clarity, right? Clarity using
Clarity.
Stacks. Also, an introduction to our next writers competition, which, again, what a time to be alive to be a writer, a technical writer, because we've been having so many technical writing competitions, and then a secret competition I'll let you guys know about a little bit later. But I'm here just to help Ryan guide you through it. So I'm going to hit Ryan, take over the show.
Sure. Thanks, Billy. Yeah, super excited. Obviously, this has kind of been on the roadmap for a while for us. We think this will be super valuable. So I'll do a quick intro. So I'm Ryan. I'm the Hiro developer advocate. I started last July or so, but I've been in the crypto space for past like 3-4 years or so. Originally started in the Ethereum space. I was head of engineering at a Rabbit Hole for about a year. And so, yeah, that's my quick little background, but I've been in the stack space for the past 2 years or so. And obviously really excited to kind of dive in here and use both of the Solidity and Clarity knowledge that I've gained over the years.
Let me know. Do you want to share the screen on that for the slides?
Yeah. Are the, see, all right, is that good there?
That looks good.
All right, cool. So yeah, so maybe actually we'll go one slide just to kind of give you like a quick hit on sort of what to expect. So for those who are completely unfamiliar with Clarity and Stacks, we'll give a very high level sort of like design architecture, what it is, kind of intro. And then I don't want to spend too much time on that. Obviously, the fun stuff is in the code. And so we'll dive right into the code examples from like the primitives, the types, how they work in relation to each other. And after that, we'll take a look at the tech stacks and we'll use Clarinet, which is very similar to Hardhat. We'll look at some Stacks.js templates, which is very similar to Web3 JS library in the ETH space. And then we'll take a look at Hiro platform as well, which is very similar to the Remix IDE. And then after that, it'll just be open to questions. And obviously, in the meantime, to interrupt with questions, I'm happy to stop and kind of resituate. But yeah, let's go ahead and just kick off the sort of high-level intro here. So Stacks is a layer 2 blockchain. It's built with unique capabilities to read and soon write to the L1 Bitcoin. So in contrast to the limited scripting language on the Bitcoin L1, Stacks has its own language called Clarity that allows for fully expressive smart contract development on par with Solidity. And so the language, in fact, maybe we can switch, Billy. There's a good graph on one of our blogs. Let's see.
I'll wait till it's ready in just a second.
Yeah, I think here. Let me grab it back. I moved it.
Sure.
Yeah, now you should be able to see that.
There we go.
Let's see. Scroll it up a little bit. Yeah. So this is a very clear sort of high level design architecture for Clarity versus Solidity. And so the language was created in 2020, about 5-6 years after Solidity. One of the main themes we'll see today with how you develop with Clarity is its focus around security and predictability. A lot of these decisions came, after being able to see some of the unknown sort of issues and security holes just in general, really, with smart contract development. And so Clarity had a good amount of data and lessons to work off of and sort of its decisions in building Clarity. And so on the compiled side, Clarity is an interpreted language. This means that its smart contracts are executed directly by the blockchain's nodes without prior compilation to bytecode, ensuring the transparency and facilitating auditability of contract logic directly on chain. So this is obviously in contrast to a lot of compiled languages like Solidity, where the code is precompiled into machine level instructions, sacrificing some transparency, maybe having to trust the compiler, And so that's sort of a pretty key differentiator there. As far as the supported types, we'll get into that more with sort of like the code examples, but more or less the same. On the gas estimation, this kind of come down a little bit to like the decidability of clarity. And so on the Solidity side, fundamentally the estimation is undecidable because it's, Turing complete. Whereas on the clarity side, there's a precise gas estimation because it's decidable. You know exactly how much a function is going to be estimated at.
Ryan, before we get into the next section, can you
Yeah.
drop us that link to that blog so I can share it out?
Oh, yeah, sure.
You could throw it in the private chat. I'm just going to switch over really quick just in case you have anything private on your screen.
Oh, yeah, that's good.
Yeah, that way people can follow along. Yeah.
No, yeah, we're good. I think I did a good job on that, trying to protect from that.
And then we do have a question as we
Oh, yeah.
are going on there. Let me grab that really quick. I'm grabbing that link. So as we go back onto the other page, we have a question of, can you tell us more about decidable? And I'm going to go ahead and post that link right into the chat. And so what does decidable mean?
So yes. So basically it limits the range of computations to ensure the behavior of smart contracts can always be determined ahead of time. And so you'll see that there's no like for loops necessarily in clarity because it's too much unknown logic that could be done in there. And so that is primarily what decidability means in that context.
Hopefully that answers your question, Tippy. But let's keep going. Let's keep it moving. For those that are just joining us, you could check on the blog link as you follow along.
Yeah, and I think let's see, which ones did we skip over? The language design philosophy.
Yeah.
Yeah. So both Clarity and Solidity are statically typed languages, meaning you must declare the types of your variables. However, Clarity emphasize there is some nuance there, and we'll see it in the code section. But overwhelmingly, Clarity emphasizes immutability, where once a value is set, it cannot be changed. And this design choice significantly enhances, that predictability that, I was mentioning before. Yeah, that's kind of one of the big differences between the design philosophies, even though Solidity, of course, you have to be, it's a little more implicit mutability versus Clarity has to be explicit immutability. And then let's see, development environments. Yeah, we'll go over the tech stacks, but pretty similar development environments on both sides. Yeah, I think let's see, what's the next?
Do you want me to switch back to the slides?
Yeah, I think next slide is should be. Yeah, I mean, we can just. I mean, if you wanted to hold there, if there's any questions on sort of the high level stuff before we jump into the code examples.
I had a general question on here, like for Bitcoin, and maybe a lot of people in the audience says, like, as far as I knew, the L1, you send it back, right? And so this concept of being able to code on Bitcoin as like a rollup or like a layer 2, how does that play a role overall? Like, are we doing it on a separate chain and then it's finalizing on Bitcoin? Are we doing requests? Is that how it works?
So I missed the first part of that. I got someone doing some. I don't know if you can hear the sawing in the back. But you're talking about the transferring
how does
and moving assets from the layer 2 to layer 1.
Well, how does Clarity play in the role? Like, is it in a separate chain and then it finalizes on Bitcoin eventually, or references Bitcoin at a certain timestamp, or wherever it goes? Like, where does this play in there?
The latter? Yeah. So right now, the Nakamoto upgrade coming is going to provide us that write ability that Stacks currently does not have, and that means to be able to mutate and change the state at the Bitcoin L1. But ultimately, right now, Stacks consensus blocks are mined on a separate chain, and then those get sent over and backed up with the L1 security after that. So it's two separate.
Nice. Nice. Very cool. Yeah, I don't know if we have any other questions. I'm seeing people some chatter, but if you have any questions, feel free to throw them in the chat. We'll share them in the screen. If not, Ryan, let's get to the code. That's what everybody's excited for. How to start building on it, right?
Yeah, exactly. Here, let me real quick shut this door in case the guy starts sawing again.
Sure.
But if we could do that real quick.
Of course. While you're doing that, while everybody's watching, and in case you're not following along on YouTube, we do have a link, and we do have a Twitter thread, X thread competition, or a blog competition. I'm going to post that Notion out here that has all the details. We're actually going to have two competitions with Hiro. The first one being a thread competition, and I might as well throw a little bit of a teaser on there. Developer DAO is also popping in another piece of the bounty for those that do the thread competition and have a legit submission. Those that do submit some or like do deploy something using stacks, show us your transaction, show us what you've done on top of your thread bound or thread submission. As I'm getting jumbled here, we're going to add another lottery on there. So anybody that actually does submit to the, I'm going to say the Stacks network, would that be the correct one? Yeah, Stacks. So anybody that basically deploys the Stacks is going to go into lottery. So any valid submission, again, just to recap, any valid submission on a Twitter thread, X thread, or a much deeper analysis that fits in a blog, if you deploy something using Stacks with Clarity, you will also be part of basically a raffle on there of all the submissions on there. We have about a $200 USDC. We're not sure how we're going to split it up. Maybe it's one grand prize or maybe two. But definitely it's an added bonus to just adding more to this thread and getting your hands dirty with Clarity and Stacks. And then we have a couple questions on here.
Yeah, there's the microblock question.
Yes.
Yeah, and so basically the way that the current consensus works is Stacks is anchored to Bitcoin's 10-minute blocks, and so obviously that's a bit slow. So microblocks was introduced for faster transaction processing, essentially. If that sort of high level answers the question, I can go a little deeper if we need to.
And one other question is the microblock concept from the Bitcoin, I don't know, NG paper, I guess?
NG paper.
That I don't know. That I'm not familiar with on there.
Yeah, I'm not too. Yeah, and Elena, that's a good point in the chat. That microblocks will go away. Hopefully in April when the Nakamoto is scheduled to release and be upgraded.
Gotcha. Okay, cool. But I think that's all the questions for now. I'm really curious, like, how do you even get started on this?
Nice. Yeah.
Let's build and ship.
Great. Sweet.
Yeah.
All right. We'll leave that there. Go ahead and we can go ahead and switch over to the browser now.
Can you make that a little bit bigger?
Yes. You just let me know when it's good.
One more. I think we're solid right there. Yeah.
All right. What number is that? 133. Okay.
Or maybe I'm just getting old. We'll see.
No, that's fine. Yeah, no, I anticipated that. All good. Okay, cool. All right. So I built this out just to sort of, I think this is a good way to sort of showcase very specific and relative code examples across the board, varying from, variables to functions, how internal functions get called, etc. So yeah, let's just go ahead and kick it off. This is, I'm sure in the Solidity world, this is pretty basic code for everyone. We're just sort of instantiating a variable here, uint, and then fundamentally a big difference between Solidity variables and Clarity variables are the mutability. So by default, Solidity variables are mutable and can be updated directly within the functions as you see here. Now, obviously, there are exceptions. You can add sort of these modifiers or keywords, constants, immutable, etc. Whereas in Clarity, this is how you would do the exact same thing. And so you'll see that this syntax emphasizes deliberate state changes using all of the built-in functions that come with the language. And so while you kind of have sort of the JavaScript object-oriented, like 1 + 1 = 2, in Clarity, everything is a function. And you'll see that as we go through some of the examples. So see here, we're using a define data var function to sort of define our variable. We're highlighting this var set function to take the original variable and change it to the parameter that we're being passed into the function. Now, there are more functions, of course. This is a defined constant, same thing. Compile error, I believe, is the case for this one. But yeah, essentially, Clarity enforces a strict and explicit approach to state management compared to Solidity. And Clarity variables that are meant to be mutable must be explicitly declared as such using defined data var, and their values can only be updated using specific functions like var set. I figured through each section, if we want to pause, if there are any questions, sorry, I'm not looking at the screen, but I can keep moving forward.
So far, so good. I think people are just following along, trying to absorb it. If we have questions, go ahead and throw it out there, and I'll stop you.
All right, great. All right, so here's a little more complex data types. So we have structs and Solidity. So we have the user contract still. We're creating a struct user with a couple properties, name and age. Solidity uses structs to define custom data types that can group together several variables. So it's here. Structs in Solidity can be mutable, and their fields can be updated after creation. And you'll see that's a big difference in Clarity. So similarly, we can create tuples. They act very similarly to structs. However, they are immutable, not mutable. And so, actually, yeah, let me go back. That's actually a good point because this syntax is really the biggest thing with Clarity I've noticed just talking to other developers is sort of in the beginning, the syntax is a little overwhelming with the parentheses. And so I wanted to show that this is a little more kind of like JavaScript-y Solidity kind of syntax that you can create tuples with, which I find a lot more helpful. And so here we're I'll just read this. Clarity also allows for dynamic collections of data, including tuples, through the use of maps. Maps can store key value pairs, where keys are unique identifiers and values are tuples. This enables the creation of dynamic, updatable collections of structured data. And so essentially what's happening here, because tuples are immutable, you're actually creating an entirely new tuple and adding it to a map. And so the maps are actually very similar to mappings in Solidity. I think we have a few examples coming up that go over the mapping stuff. But if you had a question around, if tuples are immutable, how do you change the data inside of it? You actually just completely replace that tuple with a new one with the updated information, if that makes sense.
Can you share the link to this blog or this interface on
Oh
this
yeah,
one as
sure.
well?
Sorry, I thought I did share all that, but absolutely I could do that.
Oh, is that part of the
Yeah,
GitHub?
that was in that list, but I can
Okay.
send it again. That's no problem.
Okay. Just individually, so I'm not overwhelming them.
Yeah, no, sure.
Let me go back into the code review, and I'm just going to pop that in there. And I'm going to go ahead and paste this again. And then we do have a question. If you can do the code examples line by line, I'm not sure if you have other examples in the next couple slides on there. If we can do like a walkthrough of the line. I know you're kind of like telling us the difference between them. Is there like a side by side comparison, or is there some code that we're just going to walk through?
Oh, I can. Do you mean just talk through each line? I can do that as well.
Let's see. Yeah, let's go with that, and then we'll see if Tippy responds. But let's just see, how we're doing this tuple right here.
Walk us through the code.
It might not have up. Yeah, there we go.
No, yeah, I got you. I was reading it myself. Yeah, okay. Yeah, I just want to make sure I got it. Okay. Okay, yeah, we'll start with this guy. So first line, we define our tuple. You can think of it sort of as an object. And so we use this define constant built-in function in Clarity. Again, this could be used, and we'll see other examples of functions that you can use, like define data var. In this case, define constant, it's an immutable. And then, and then here we have it grayed out, but I can walk through it. So let is a built-in function that allows you to sort of assign sort of what you think of like local variables. And so in this particular case, what we're doing inside of the let is we're assigning a new local variable name called username, and we're using the get function to grab the name field here out of this user tuple. So if that makes sense, I guess we can kind of, I didn't want to sort of highlight that too much because I sort of had a progression, but that's basically what's happening in that let. And then here, so the defined map, this is very similar to mappings, a way to sort of like assign and add a bunch of complex, a collection of data. And that could be uints, it could be pretty much any type that you'd want. Key value pairs essentially is what defined map expects. And so this first line here, we have the name of the map, users. The key is going to be a uint, and the value is going to be of a name and age tuple. And so on this line here inside of our public function to add or update a user, we go ahead and call the map set function for that name, users. And so the user ID that will be passed in is the uint for the key. And then we pass in that tuple or struct in the Solidity realm into that map. And this is just a different sort of syntax that you can use to build that out.
Nice.
All right, so functions, modifiers, and state mutability. This is actually, as I was going through this, I kept sort of focusing on like, what are the differences? What are the differences? Because there's so many differences. But this is actually one where there's pretty similar in terms of not necessarily the modifiers, but sort of the exposure of particular functions in terms of their privacy and who can call them and how they get used internally and externally. And so here we're highlighting sort of in the Solidity code that we have a private function here called increment age. We have a sort of a pure view that's, it's not pure. It's you might want to help me on this one, Billy. View is basically like read only. It doesn't mutate any state, but it'll, yeah, right. And then the public function, of course, is able to call its own private function above.
Quick question from James. Stepping back to the tuple, can we do it like that in a function where you just have it in the brackets?
No, so all functions must be defined at the top level, essentially. So there's no defining of a, well, so you can't define it inside of a, say like a variable or a constant, but you absolutely can have a tuple type inside of a function, if that's a more of a specific answer to that question.
I hope so. And then just a quick question, we might be a little bit ahead of the game here. Will there be examples of a contract call to another contract?
Yes.
Okay. Awesome. We'll get to it.
Yeah, I hope I've covered a lot. There's some I wanted to add, but yeah. Okay, so we can so this is just highlighting that the public function can has access to call a private function. And so we'll move over to clarity, and you'll see very similar, albeit a few different names. So we have, instead of a modifier on the Solidity side in the functions, you have the actual built-in function itself that states the type of function it is. So this first one here, we have defined private, and this is pretty much just a one-to-one from the Solidity code that we saw earlier. So we're calling that var set function again, and we're taking the user age, and sort of this is what I was kind of explaining for the math, even adding in the math, everything's a function. And so you have this, the parenthesis with the plus sign is the addition function, and the first argument is the first number item that you want to add to the second. And so jumping down to define read only, that is just like the view that we saw before. It cannot mutate any state. It just reads state from the current contract or other contracts. And then define public ensures that it doesn't have to mutate state, but it allows state to be mutated.
Gotcha. Real quick, we have a question. I think I'll take that one. What about external? So we were looking at public, views, and private. External is like public, where you can call it from outside, but you can't call it internally. So it's kind of like a gas saving thing instead of public in Solidity. So
Correct.
if you only want it to be called from the outside instead of the inside, you put it as external instead of public to save a little gas. Kind of public's like a catch-all in a sense for both external and internal. So hopefully that answers your question, Black.
Yeah, that's a good call out. And
Yeah.
to make that distinction and clarity, so that there is no as long as a in clarity that a function is public, there is no sort of like internal only or external. It's just public. And so yeah, so we kind of already talked through that. And then here, the define read functions are used to find functions that can only read from the contract state. And then yeah, I'll leave that there for a minute for people to soak it in. All right. Hey, who was the one that wanted the calling functions section?
That was Van.
All right, here we are. Okay, so here we have it, the similar setup in Solidity. We've got a variable. We've got sort of a mutating function there to update the new age. And then inside of another contract, the way that you would call an external contract, or one way, in this particular case, if they're in the same file, I didn't want to add like the import and stuff, but as long as you sort of, and are sort of, is it, as long as the interface is available in that particular contract, Billy, is that correct?
Correct. Yeah.
Okay. So yeah, so that's how it's done, Solidity. And so on the Clarity side, oh no, I messed up. I knew it was going to happen. I wanted to highlight the increment age. So if you look inside at the define public function right here, that is how internal functions get called. And on this line here, this is how the external functions get called. So again, it's a built-in function called contract call, and it takes the principal or the address of the contract that you want to call, the function name, and then any parameters that that function name might have.
Again, if you guys have any questions with that, go ahead and post it out there. We'll recast here.
And also, I also added this to, or actually, I'm not sure if I did. See, where's, no, that's,
As you're looking for that, we actually have a pretty interesting question. Is it possible to change the contract after deployment, like a proxy pattern or like a UUPS, like in Solidity, where we can like have a 3 contract system where one holds the data, one points to the functions in a sense? Is that available on a on Stacks?
I feel like proxy. Yes, I feel like proxies are possible. I'm blanking on like an example, or how like technically to describe that, but I'm pretty sure I've seen discussions around that and people using it. Sorry, that's a kind of a weak answer, but I do think that's possible. And so, is this more like a? There is a concept of, I was trying to find that functions page that I sent you earlier, that you can kind of look at all the built-in functions for clarity. Let's see if I can just find that real quick.
I'm just going to switch over as you
Yeah,
compile
sure.
that.
Yeah, thanks. And so there's, I mean, maybe we can even just take a look at that really quick, or maybe we just finish this guy and then we can kind of go off on some tangents.
Yeah, we'll circle back on you, Van. It was a good question. It's kind of interesting on how complex the stack is, right? Like, can you start throwing out proxies? Can you start refactoring stuff from EVMs to stacks? You know.
Right. No, that is a good question. I'll have to do some digging myself on that one. Okay, great. All right, let's see. So let's go ahead and jump into events and logs. So I guess one huge difference here. So here we have the Solidity code. We are actually declaring and defining the event itself, and then in order to emit that, I guess this is the emit keywords. Are these the right kind of terminologies, Billy? I think for Solidity.
What was the keyword?
Is you just emit an
Oh,
event.
yeah, to emit an
Yeah,
event. Yeah, yeah.
yeah. And so in it's definitely more of a explicit and manual sort of approach for events and logging in Solidity. And while in Clarity we have a print event primarily. That is the only. There's no like custom or creation of a particular event to then call and execute inside of a function. You just use this print function, and you can print any type. You can print strings. In this case, we're printing a tuple. You can print pretty much anything out, and that will log out as if it's an event on same way as like on Solidity. And one additional thing that's also important is built-in functions themselves may automatically emit events. So in this particular case, of course, you can add a print statement after the stacks transfer function call, but stacks transfer itself will actually emit a print statement with information about that transfer.
Awesome. Also, Arcs just put up a really, really good comment on here. So Clarity has a state isolation. So contract A can only change the state of that contract. Contract B cannot change the state of contract A currently. So thank you, Arcs, on that one.
Oh, okay. Yeah, that was the answer to that question. Jeez, that's great.
Yeah.
Um,
and Van, with all the questions here, I appreciate the questions, Van. Are there any subgraph analogs for stacks?
Subgraph. What is? Yeah, let me look into it. Subgraph
Like,
analogs.
I'm
Oh,
assuming indexers.
you're talking about like, yeah. So like indexing. Is that kind of where Van's going with that? Like
I think
indexing
so. I'm
services?
waiting for the response too. I'm in suspense on this one. Yeah. As we're waiting for the response on that one, we do have one other question. I love the questions, guys, because it really shows that you guys are super interested. Bitcoin's awesome, man. Like, it's the king, right? We have another question. So does that mean we have factory contracts?
Oh man. In fact, but can you remind me, Billy? I know in my Ruby on Rails days, I'm kind of blanking. Does that mean factory
Like
contracts?
a contract can deploy another contract is what I'm assuming on there, where you can have
No,
this thing with the bytecode.
no,
No.
no, it cannot. Sorry, I should have known that quicker. But yeah, no, that's not possible.
No worries. And apologize to everybody. My camera's off. Like, my water heater broke, but I'm a pro,
Oh, it
so
happened.
it happened.
You warned. You
So
finally did.
I'm
It finally
working.
happened.
I am working as we are fixing issues, so my camera's off for just a little bit, but I'm still here. I'm here answering questions. I'm resolving the issues, but we're good.
That's great.
Go for it, Ryan.
Cool. But anyway, I guess I can, for Van, I can assume. So we, at Hiro, we actually have a tool called Chainhook. I thought about it. I'm not sure if we had enough time to kind of go through that one, but it's basically similar to the graph and how you build out subgraphs to sort of like index and capture event data from smart contracts. And so I don't know if that sort of answers that question, but if it was along those lines, then yeah, we have a tool called Chainhooks. All right. Okay, so I guess we'll pop into access control. And so, so Solidity obviously has the ability to create custom modifiers for their access functions. In this particular one, we have a modifier called only owner. This is probably one of the more common ones that you see, using the sort of the require statement to make sure that the owner is the one making the call to this contract. And then in defining the definition of your function, change owner, let's see. Oh, I screwed that code up, didn't I? Hey, Billy, can you catch the error in there?
Oh, it has to equal the owner, and then it's a modifier on there.
Well, so this code, so the change owner has the only owner modifier in the definition of the function, and then I removed it. Oh no, I did remove it on purpose. I didn't, because I now hard coded require.
Yeah.
Yes.
You're good.
I'm tricking myself.
Yeah. Which kind of leads me to another question on this. Yeah. So this is referring to like the Open Zeppelin libraries that have a lot of these these pre-built like
Yeah.
standards built into like ERC20s, ERC17s. Like we always refer to the Open Zeppelin. Is there a Bitcoin library that's equivalent to the Open Zeppelins that have these pre-built-in modifiers and standards?
No, there are, of course, standards, but there's no external libraries to import in and sort of like inherit from because there's no inheritance. Um, and so it's function driven language, and so there's it there's templates and there's sort of like standards of like what you should be checking for and what sort of built-in functions. In particular, there's like TX sender versus contract caller, where there's like conversations around, but nothing like the Open Zeppelin libraries that you're referring to in Clarity.
Got it. Got it. And we have another question from X. Which products will be built with this? And I think that's kind of like a generic one, right? Because you can literally limitless, right? In a
I mean,
sense.
at this, so I've heard, I don't know if there's stories, but like or if they're true or not, but because the sort of Turing completeness and fully expressiveness of Solidity, and then sort of this decision on the Clarity side to be a bit more like predictable and security oriented and sort of limited in the scope of for loops. There was sort of this idea of like, oh, there might, like, it's fully expressive smart contracts, but you might not be able to do everything that you'd want to do that you could do on the Ethereum side. That turns out not to be the case. Uh, Pretty much, so to answer that question, what can be built is just fork whatever idea you like over on the Ethereum side, and start learning Clarity and build it on stacks.
And then just a quick comment from Arcs, composition over inheritance with Clarity on there. It seems to be the way to work. Yeah.
Yes. Yeah. Mainly because inheritance is not possible. All right, and so moving over to access control on the Clarity side. So we have this asserts function. This is very similar to the require function. And we have some other functions here. So we're running like it's pretty, so I don't know if, when I was making sort of the switch from, writing a bunch of Solidity, I obviously had like, like object-oriented background. So it did come very natural to me. But over time, sort of the readability of Clarity, I mean, it's very clear to me what this sort of means, right? It's like it's is equal sender is this value, else error out. And so like you'll kind of, as you dive into these functions and you dive into sort of the ecosystem, that's definitely something that myself and a few others have sort of noticed. Anyway, that was kind of an aside, but essentially access control is rendered through this asserts. Basically what happens here is if inside of a public function, which this is, this response type returns not an okay response, but an error response. If there were any sort of state mutations that were occurring either down the line or above it, will get rolled back and reverted. And so this is very similar to what I believe, and you might want to help me out here, sort of like the revert in Solidity, but you kind of have to control that manually. Is that right, Billy? Oh, did we lose Billy? I'm solo, y'all. Anyway, I'm pretty sure that revert and Solidity is kind of that process. So the big difference is you have asserts built-in functionality that will automatically revert any sort of state mutations, whereas in Solidity, you have to make sure that you're sort of making that call out and using revert to handle any sort of unnecessary state changes. All right. So now let's get to some practical examples. And so here's an example in Solidity where we're just transferring some ETH. We'll notice here the payable modifier. So this allows the function to send and receive ETH. And the to address is also marked as payable to allow it to receive ETH. And so now in Clarity, Sending stacks involves calling the built-in function stacks transfer. The function inherently checks if the transaction sender has enough stacks and if the transfer is possible, making the code much more straightforward. I'll go ahead and keep moving forward. I'm not sure if the logs have stopped or if there's no more questions. And so moving from native to fungible tokens, we have here basic interface IRC20, the most common one in Solidity. Basically has a transfer function built on it. This is kind of to Billy's point about the Open Zeppelin libraries. You have all these functions and modifiers that come in with this interface. You simply call the transfer function off of it, and that is the Solidity code. And then here we have contract call again, because we're making a contract call now to the token. We call the transfer function on it. We pass it the amount. TX sender is essentially msg.sender. I don't think I mentioned that at this point, but TX sender is very similar to msg.sender in Solidity. And then you send it to the recipient. And so I think, well, our ERC 720, the equivalent on the Clarity side is a SIP10 for our fungible tokens. And so, yeah, let's see.
Got it. Sorry about that. My mic was getting killed and I like kicked myself off the switchboard. So I was talking to you and I couldn't hear myself.
I didn't see your little bubble, so I was like, okay. And then the chat was kind of chill, and I was like, all right.
Yeah, yeah. I mean, going back to the piece that I'm saying right now, like it almost seems like Clarity is kind of like nearly a line by line conversion almost, where you have your functions and then you kind of like just got to like put them side by side and you can kind of refactor almost everything in Solidity in stacks.
Yes. I
Yeah.
mean, going through this sort of exercise, it kind of came to that. It was obviously fun to sort of step back into the Solidity space and sort of pick up where I'd left off. But yeah, I did notice that through this exercise, and it really is. I mean, it's really just a matter of like putting out enough content that sort of makes that clear and obvious. Because I don't think it's I don't think it's at a state now where it does make it that clear and obvious. And so hopefully we can get there real soon and make this super easy for people to kind of pour over and build all the cool stuff that Ethereum has on stacks.
What an opportunity to remind people that we are having a Twitter thread contest, also a blog contest as well,
Cool.
that kind of like deep dives into this.
Yeah.
For those that come in late, I'm going to reshare that Notion doc on there that has all the information. We're actually going to have two competitions, one happening this month and then one happening after the popular ETH Denver. But for right now, this one is going to be a thread competition where you're basically comparing Solidity to stacks or Clarity. I keep getting those mixed up. But then you are basically a thread, and then Developer DAO is also throwing in a little extra bounty, kind of like a lottery. If you deploy something using Clarity and stacks, and you show us your deployment, you're just going to be put in for a raffle on there. So if you do a blog submission or a Twitter thread submission on here, follow along in the docs. You'll see where to submit. Don't get confused because we do have two competitions, but the sign up is right there on there. It's a Luma sign up doc, so we can send you reminders and keep you up to date. And then we have our deadline as Wednesday, the 21st, but that was assuming we were going to do our workshop on the 14th for Valentine's Day. But we might move that to Thursday if people need more time, but we're keeping it Wednesday, the 21st for now, get you the weekend to grind. But if there is a community shout out to say, hey, we want one more day to get a better quality one, then we will adjust it. Anyways, Ryan, go for it. Keep going.
No, yeah, all good. All right, so yeah, going through the practical examples. So now we're looking at the non-fungible tokens. Let's see. This is more or less very similar to the ERC 720. It's just transfer from now. So we'll try to move through these a little bit faster. But just anyone in the chat, if it's going too fast, just let us know. Very, very similar. Obviously, just a different schema of the functions here since we're passing a token ID rather than an amount. But we're still calling the contract call function. We pass in the principal, in this case, the NFT contract. We call transfer, and that's pretty much it. And similar to SIP10, and similar to SIP10 and ERC 720 and ERC 721, we have SIP9 for our NFT contracts. And, you know, now
And
that
just
I'm
just for those curious, we are going to do a bunch of all the links on there. It's going to be filled up on the Notion doc at the very end. I'm just grabbing all the links so that way you have references and everything, so you're not stuck to the video and you can, always reach out. Also, for people that are following along and they may have questions after this workshop, what's the best place to go? Is it the Discord? Is hit you up directly? What's the path moving forward?
Yeah, I mean, hit up the Discord, but I'm definitely open. I mean, I think you have my information right on Discord and Twitter. I love I love answering questions and engaging with everybody. So just I don't mind anyone hitting me up on any of those platforms.
Awesome, awesome. Okay, yeah, I'll make sure to have that. For those looking at the Notion doc, the Discord is there. I don't want to share too many links in the YouTube because people get link clicky. So
Mhm.
the Notion is the source of truth, guys.
And yeah, so for the examples, obviously this link has been shared. I'm gonna definitely continue to sort of add to this. I think this is sort of I think this is a good resource to sort of add to. And so I'll definitely check back in, you know, as I sort of improve that. And then I guess, yeah, as far as time, Billy, um, we can do a brief sort of overview of the tech stack, and then we may not have time to go through like each one of them. Um, but I can kind of do a screen share of sort of using one of our tools. I don't know what I mean. Do you have like a hard stop, or we can keep going?
I have a hard stop at 9, unfortunately, but we can do a quick overview, and that's kind of sort of the challenge on there as to kind of want to cover what we're looking for in the Twitter thread and blog contest too for those
Oh
kind of
yeah,
curious. Yeah.
for
Like what
sure.
are you looking for? Because obviously we've done a line by line comparison in this blog website. So what are we looking to expand off of this?
Yes. So let's look at the we have it in the slides. Where are our slides at here? Um, so we got like 10 minutes or so, 12 minutes.
Yeah.
So we'll leave it here on this slide. This is basically just a one-to-one. You know, Clarinet is our full development environment suite where we can, you know, run local networks. We can test our local contracts. We can deploy to all the networks. You know, spinning up a local environment automatically deploys your contracts locally so that you can test them. Um, there's commands, and I can share specifically the docs for Clarinet, where you can generate deployment plans for testnet and mainnet for your contracts. And then it's really just a matter of like 2 or 3 commands that you can run to get your contracts deployed using Clarinet. So very similar to Hard Hat, if anyone's familiar with Hard Hat. Stax.js, very similar to Web3.js, basically just a suite of packages and libraries to interact with smart contracts via front end, and not just front end. So because there's so many packages, there's CLI packages. Yeah, it could be used with React. We have like use hooks inside of a connect library with Stax.js. So if you're familiar with Web3.js, Stax.js is pretty familiar to pick up. And then same thing with platform. If you're familiar with Remix cloud-based IDE, platform is kind of like the UI. Like if you put Clarinet and Stax.js together and have something that you can just click around and do everything that Clarinet does, that's pretty much what platform is and more. And so I think I have those links that I shared in the long list with you, Billy, so people can go take a look and check that out. Yeah, here's where I was going to do a demo. Let me see if we can come back and maybe we can get to yes, Clarity. Yeah, Clarity Tools is another good one too. We might have time for that. We've been doing the Q&A. Okay, so do we want to go over this, Billy, before we?
Definitely. Yeah, we can definitely.
Yeah.
I'm pretty sure people are kind of like foaming at the mouth for this.
Yeah. Okay. Yeah. Everyone's just like, yeah, yeah. Come on, dude. Got
Yeah.
it.
Yeah.
Um,
Mhm.
okay, great. So yeah, so we got a couple bounties. 7K in total. We have a writing bounty and we have a technical bounty. And so the writing bounty examples, we didn't. I can give. So I don't want to give away the answers and really talk too much about BNS. We did touch on revert a little bit, but as you can kind of guess, BNS is more or less similar to ENS, and so basically being able to sort of like write out sort of like the distinctions and similarities of those two is one. Revert and post conditions. So post conditions isn't something that we talked about on the Clarity side, but and it's also not something specific to Clarity language itself. It's actually has to do with the nodes on a transaction level in terms of protection around unwanted sort of state mutations. You can find a lot of information on that. In fact, before we leave, I'll throw in a link for post conditions. ERC 721. Actually, this SIP 11, I don't think a SIP 11 is a thing. I think what it probably means is SIP 9. So basically NFT contracts. So the difference between the interface of ERC 721 with our version, which is SIP 9. And then we have ERC 20 versus SIP 10, BRC 20 versus Stacks 20. Again, I can share some like high level links to get people started on these. I don't want to like give away the answers of what the differences of these things. But yeah, that's the writing bounty. And then the technical bounty, that's for, I guess, our workshop too.
Yeah, that's going to happen in March. Right now, we just want to get you used to Clarity, get you familiar with it. And then again, remember that we're going to have the raffle for those that do the like a deployment on there. And then we're going to have a follow-up one, excuse me, with a workshop where you're actually going to build a small DApp or build a big DApp if you've been working on something. And it's going to be more of a technical thing on there. So for those DApp builders out there that say, hey, what about us? It's coming. It's going to be coming in March, and it's a much bigger bounty. And then it's all going to be on Bitcoin, so you're going to need a Bitcoin wallet. So it'll be fun. I'll be interested on there as well. Just don't get confused between the two. So I've separated it in the Notion. First one's going to be a writer's technical blog thread workshop, third challenge with a deployment bonus if you want to. You don't have to. You can just do the thread only. And then the second one's going to be a technical bounty. We're going to bring that back up in March after the noise from ETH Denver kind of dies down a bit.
Cool. And we've got a few minutes. I guess I can, I'll hop over to Hiro platform. Is my screen still being shared?
Yes, I can switch it back over. Yeah.
All right, cool.
And hard stop is like a soft 2-3 minutes anyway, just in case. So
yeah. I'm just gonna like really run through this. Obviously, the links are there. You can sign up for an account, connect your wallet. By the way, we do have leather wallet links and all that. But so essentially, here's my projects page. I can go here to create a project. These are our templates, and we're looking to add a lot more of these templates in the next few months. And so here we can just we'll do like an NFT marketplace. So I'll go ahead and click that. Start workspace. And so basically what this is doing is it's basically just creating, it's using similar functionality that Clarinet has to sort of generate and scaffold a bunch of projects for you. It's just doing it purely through the UI. And so, yeah, we'll wait for this guy to load.
As it's loading, we have a quick question on there. Is that, will you be at any of the Bitcoin developer trainings this year? London, Atlanta, Austin? Where can we find you?
Well, I'm in Austin, so I'm definitely going to that one. I would like to go to the rest. I definitely will try. But yeah, the plan is to answer the question succinctly. All right, so okay, and here's chain hooks. I don't have time to go into that, but all right, so I don't need to collect. I don't need to do that. That's silly. All right, so open editor. And so now I've got this cloud-based IDE, and we'll go ahead and take a look. And there we go. So we've got a nice little NFT marketplace contract that we can kind of play with and toy with right here. And then if we wanted to deploy it, I can click this button here. And this is very similar. Basically, the way it works is for deployment is you generate a deployment plan for a particular network, and then you deploy to that network. And so in this case, I can, let's see, we'll just generate for mainnet.
And guys, you don't have to deploy to mainnet. I know that costs real money.
Right. Anyway, so yeah, so that's Hiro platform. And then obviously probably don't have enough time to go into sort of this real world application that's super interesting. If anyone's somewhat knowledgeable about Lido, the liquid staking platform, this is more or less our version. It's a liquid stacking platform. We call it stacking, not staking. But yeah, I encourage you to check that out too. I'm not sure I actually sent this link. I can throw that in there real quick.
Yeah, for sure.
Let's see where are all these tabs going. Okay.
And for those that are looking through the Notion, just kind of throwing it out there, there are job opportunities with Hiro on there. So just in case, and this
Yeah,
is
for
all
sure.
interesting you, and you're like your eyes and your ears are perking as you're listening to all this, and you're really interested in Bitcoin halving coming like really soon, right? It's everybody's going to be talking about it. It'll be all over your timeline. But there are opportunities for jobs at Hiro, and I'm not sure if the submissions are going to have any relevance to that, but I'm just saying contributors are probably favorably looked upon versus random submissions, right? So just a heads
Yes,
up. Yeah.
definitely. And also, the plan was to kind of dive into some of the code, and this is a work in progress too. So I'll just share this little blog that I was playing around with as well. Um, I have the first function broken down so people can kind of take a look and explore a little more like complex clarity contracts if they're up to it. So
And I'm going to be grabbing all these links and then posting them on the bottom of the Notion. We have a resource center here. So all these links I'll be grabbing and just popping them all in there on the very bottom. So if you feel like you're lost or you're not catching up, you can always go back to this video. The videos link to the Notion as well. So you can always refer to this if you get stuck. And then if you totally get stuck, hit the Discord, hit up Ryan, hit him on Twitter, share the socials, whichever. Follow Hiro, follow Ryan. It's all in there.
perfect. Awesome. All right. Are we good? We up on time?
We got a few minutes. If there's any last minute questions or any like wise words for those ready to jump in and just start playing around with everything. And I'm just checking the comments right here.
Yeah,
Everybody's
that's
just
me.
saying thanks. So I think it was pretty efficient. We were worried about it filling the hour, and we're
Yeah, I was
right
over
here
here going,
tapping
man,
the
I
hour.
don't think I'm going to fill an hour. And it was like
Yeah,
10:50. Yeah.
yeah. And then my oh, 1 second.
Uh,
Quick
Test and
question
debug. Oh,
on how
yes.
to test
So
and debug.
let me send that real quick. We have Clarinet SDK, which is fairly new. Here's a sort of a direct link. Um, Send that over as well. Good call out. Good call out, man. And also in Clarinet itself, there are command line tools to sort of validate your contracts. And there's a local REPL called the Clarinet console that you can go into and actually play around with your local contracts as well. So there's like testing suites that are separate, plus the actual local debugging on the fly inside the terminal.
Very cool.
Great.
I think so. All right. Yeah. So sorry, there's a little bit of noise in the background. Once again, my water heater has been broken and now we're trying
All
to
right.
fix it so, without hot water. So apologies for the camera things, but sometimes things happen unexpectedly and you got to roll with it. All right. But thank you so much, Ryan. We're going to kind of end it there. Sorry for the noise in the background. I think people are just doing major movements, but if there's any questions, we're going to follow the Notion. Reach out to Ryan for any issues. If you have any questions and you just can't find anybody, hit me up and I'll relay you to the right person. But looking forward to the competition, looking forward to see the threads, and hoping to see some deployments out there. Remember, it's just testnet, not mainnet. You don't have to use real money. If there's no guide or you can't find an easy way to find a guide to get test tokens, that could be a nice guide too. Just FYI. Cool. Thanks again, guys. Thank you so
Thanks,
much,
Billy.
Ryan.
Thanks, y'all.
All right. I'm going to end the stream.